Windows NT Advanced Server has a lot of feature functionality that now allows us, the MIS shops of the world, to take these mission-critical apps and actually apply them to these really tough problems.
One of the really great things about Windows NT is that with a single network logon, I can access resources anywhere in the network where I've been given permission.
Well, Windows NT Advanced Server's openness has made it really easy to integrate it into the diverse network we have here at Microsoft, which includes Windows, Macintosh, and DOS clients, as well as AS400 systems, VAX systems, and several flavors of Unix.
Hello, I'm Wesley Rice. You've been listening to three of the people responsible for the reshaping and upgrading of the Microsoft Worldwide Network to Windows NT Advanced Server. They will offer the benefit of their experience so that when you plan your company's network, the flow of information and the methods of protecting that information will meet your company's business needs. In addition, Microsoft's Director of Global Networking, Dave Lineweber, will give us his perspective on client-server computing and specifically the role of Windows NT Advanced Server in implementing Microsoft internal business applications. Then we will describe what client-server computing means under Windows NT Advanced Server, both to the administrators and to the users of local area and wide area networks. Keith Logan, Lead Program Manager for Windows NT Administration, will review the functional characteristics and features that customers require for this powerful client-server operating system. Dan Perry, a Microsoft Product Support Training Specialist, will provide an illustrated overview of Windows NT Advanced Server concepts and 4 suggested models for organizing your network. In addition to discussing the applications of these concepts and models, Debbie Alsop, a corporate network engineer, and Alan Jurgen, Microsoft's corporate computer operations manager, will demonstrate several administrative tasks by using the Windows NT Advanced Server graphical user interface. In the final segment, we will respond to some of the most frequently asked questions about Windows NT Advanced Server. After you watch the video, we recommend that you review your Windows NT Advanced Server Concepts and Planning Guide, which provides more detailed planning information as well as examples and scenarios to illustrate the concepts. If you are upgrading your network from LAN Manager to Windows NT Advanced Server, see your Upgrade Planning Guide for LAN Manager. You may want to reset your VCR counter to 0 now so that you can easily make note of the places in the video you want to return to. In the last few years, the network industry has been moving steadily toward microcomputer and multiprocessor client-server platforms. Windows NT Advanced Server is a natural extension in this trend. Here's Dave Lineweber with his perspective.
So for me, Windows NT Advanced Server really represents a new generation of client-server computing that will allow us to take on more mission-critical applications, to take those things that have been running on mainframes and to put them down into an area that's really much closer to the reach of the end user. It's interesting to me that that's exactly what client-server architecture is really designed to do. That it really strikes a balance between this distributed and centralized data. That's its greatest strength. The ability for you to develop a system that allows an MIS shop from a central location to really manage the data, but still keep the data out there close to the people who are actually turning that data into information. So that's the challenge of the MIS professional today, is to take all of those islands of information and to be able to join them together in cohesive enterprise-wide networks that allows the information to flow very, very freely between individual users within the company, and also to flow up to the senior managers who are trying to make those day-to-day decisions.
Windows NT Advanced Server's client-server architecture can make use of data and resources more effectively and less expensively throughout the entire company. Windows NT Advanced Server is the server version of Microsoft's Windows NT operating system, integrating mission-critical applications and personal productivity tools. But what exactly do we mean when we say client-server operating system? And how does that functionality increase the efficiency and lower the cost of your company's network? Many people do not realize that what is offered by client-server architecture can differ significantly from brand to brand of network software. Generally, client-server architecture splits application processing between a front-end client component, which runs on the PC workstation, and a back-end server component, which runs on the PC server, minicomputer, or mainframe. On the front end, the client part of the application typically consists of an easy-to-use graphical user interface capable of presenting and manipulating data. On the back end, the server application is responsible for storing, retrieving, and protecting data. When it receives a request, the server processes the request and provides the requested service to the client. But what makes Windows NT Advanced Server the most powerful client-server platform is the ability to run mission-critical business applications on high-performance PC servers. The presentation services and application-specific processing that an individual user needs are handled by the PC workstation. Windows NT Advanced Servers handle the work that is most processor-intensive and that must be shared among users. The greatest benefit to the users is improved performance. Much of an application's processing is offloaded to the high-performance server hardware. Essentially, this gives the user at the PC workstation a boost in computing power, and it preserves your company's existing investment in PC hardware. The centralized processing services reduce network traffic, provide improved security, and centralized administration helps to ensure the integrity of the data. In addition, the user-friendly graphical interface of the system reduces training costs. Now let's turn to Windows NT Program Manager Keith Logan, who will review the functionality that makes it possible for Windows NT Advanced Server to run powerful business applications with the high reliability offered by advanced fault tolerance. Keith will also show that Windows NT Advanced Server is open, which makes it easier to integrate into mixed networks.
When we asked our customers for their requirements several years ago for our new operating system, Windows NT, they told us they wanted a powerful operating system on which they could deploy client-server solutions. In general, their feedback fell into the following categories: power, reliability, and openness. They told us they wanted a high-end operating system with 32-bit processing and preemptive multitasking. In addition, they didn't want any bottlenecks in the system, so we made Windows NT scalable so it can run on single processor machines and also scale up to symmetric multiprocessor or RISC architectures. In addition, there are no built-in capacity limits in Windows NT. Files can be as large as 17 billion gigabytes, effectively removing all storage limits. As well, Windows NT can address up to 4 gigabytes of RAM. Customers also told us they wanted it to be easy to share information from these systems so they could exploit client-server computing. Networking and workgroup computing capabilities are built into Windows NT and Advanced Server, and the graphical administration tools in Advanced Server make it easy to centrally administer these systems. One of the most important pieces of feedback we got was that administrators wanted a user to only have to log on once to access any resources in the network. This single network logon means that a user only has to remember a single user account and password, where an administrator, since there's only one account to deal with, only has one account per user to manage. Finally, people told us that they wanted us to retain the simple Windows user interface so that their new business-critical applications could integrate well with personal productivity applications and not lose the existing investment they have in training. Windows NT Advanced Server's power makes it a system you won't outgrow. Its symmetric multiprocessing support, its portability to other architectures, as well as its large capacity and centralized administration, ensures that it'll support your business needs as your company grows. In terms of reliability, customers ask for a number of features. Perhaps the most important feature in Windows NT Advanced Server is application protection. Application protection ensures that your server will be highly available. One application can't crash the system or another application. Windows NT's preemptive multitasking ensures that one application can't delay another, and memory protection ensures that one application can't corrupt another's address space. Customers also asked us for centralized security to guard against malicious users or user error. A user can only access data to which they're authorized. Windows NT's security is designed to the government's C2 security requirements. Its flexible central management tools make it possible for an MIS administrator to control the network if he chooses so, or to allow users complete control of their desktop. Finally, Windows NT Advanced Server includes a number of fault tolerance features to further improve its reliability. The NTFS file system offers quick recovery in the event of a power failure without the need to run check disk. Also, Windows NT Advanced Server includes some data protection features such as disk mirroring, disk duplexing, striping with parity or RAID 5, integrated support for uninterruptible power supplies, and a backup program. These features make Windows NT Advanced Server the most reliable platform for client-server computing. It protects your business-critical information with quick recovery and fault-tolerant features that make sure your data is highly available. As well, tightly integrated security protects against malicious tampering or user error. Customers also ask that we provide them with an open system. Windows NT Advanced Server is open in that you can choose what type of hardware you wish to run it on. It runs on Intel 386, 46, and Pentium systems, as well as RISC-based systems such as the MIPS R4000 series or the DEC Alpha chips, as well as symmetric processor systems from each of these architectures. Openness also extends to applications. Our customers told us they wanted to integrate their business-critical applications with personal productivity applications. So Windows NT and Windows NT Advanced Server support MS-DOS applications, 16-bit Windows applications written for Windows 3.1, 32-bit Windows applications, as well as OS/2 character-based and POSIX-compliant applications. Given this flexibility, the user can choose the right application for the job. Customers also told us that Windows NT should be open with respect to networks and protocols. So we built Windows NT Advanced Server to work with your existing network. Windows NT Advanced Server is interoperable with LAN Manager, Novell NetWare, DEC Pathworks, Banyan Vines, Unix, and SNA networks. And in addition, both Advanced Server and Windows NT include TCP/IP for internetworking and OSF DCE-compatible RPC for distributed applications. In addition, Windows NT Advanced Server supports clients including Microsoft Windows, Windows for Workgroups, Windows NT, MS-DOS, and OS/2. Using Windows NT Advanced Server's services for Macintosh, Macintosh clients can connect as well, and remote clients can access the network over phone, X25, and ISDN lines using Windows NT Advanced Server's Remote Access feature. Windows NT Advanced Server's openness gives you the choice of hardware, software, and networking that's most appropriate to your business, and the flexibility to change that as your business infrastructure changes. In sum, Windows NT Advanced Server is the most powerful, reliable, and open client-server platform for the enterprise today. Microsoft also offers other enterprise services such as SQL Server, SNA Server, and Microsoft Mail that take advantage of Advanced Server's capabilities to provide advanced database, SNA connectivity, and messaging services.
Planning is integral to the success of any network, making sure that the structure of your local area and wide area networks supports your business needs. Sound planning, in part, relies on the designer's understanding of the basic concepts of the network software. Dan Perry of Microsoft Product Support Services will introduce us to the security model for Windows NT workstations. He will expand this security model to include server security with concepts such as user accounts, local groups, and global groups. He will describe Windows NT Advanced Server domains as well as the single network logon.
Windows NT provides a number of security mechanisms to assure that only the appropriate users are allowed to log on, access resources such as files and printers, and perform server administration tasks. To implement this security, each Windows NT station maintains a database of user accounts. Each person who will be allowed access to this station must have an account in this database. The user account, created by the network administrator, includes a unique username and a password. Please note that when typed into the actual system, passwords are always displayed, stored, and transmitted in an encrypted form. In order to use a Windows NT station, a user must first log on. The logon information the user must provide includes a username and password. The password provided is compared to the password stored for this user in the user account database. If the passwords match, the user is allowed access. Similarly, when the user attempts to connect to another server on the network, the user's logon information is sent to the remote server and is compared to the information stored in the server's user account database. If the passwords match, the connection completes successfully. Administrators can specify additional restrictions that will be enforced when the user attempts to log on or connect to a remote server. These include during what time of day or from which workstations the user is allowed access. To ensure that only the appropriate users are allowed to access a server's shared resources, such as disk files, printers, and client-server application communication pipes, the user account can be assigned specific access permissions on specific resources. For example, a certain user might be assigned permission to read from, write to, or delete specific sales history files. Another user may be assigned permission only to read from the same files. In addition to resource access permissions, the user account can be assigned user rights to perform specific server administration activities such as managing user accounts, backing up and restoring files, and shutting down the server. Users who have similar jobs or resource needs can be assigned to groups. Although you can grant resource access permissions and user rights to an individual user, groups generally make granting access permissions and rights more convenient when multiple users need access to the same server resources or will perform the same server administration tasks. To make network administration easier, Windows NT contains a few special built-in groups, such as the Administrators Group and the Backup Operators Group. These built-in groups are pre-assigned a specific set of user rights. For example, all users assigned as members of the Backup Operators Group automatically gain the right to log on locally, back up and restore files and directories, and shut down the system. Within your organization, you may want users to be able to access several servers. Now, this would normally require that the network administrator create a separate account for each user on each of the servers. This turns out to be a lot of administrative work, especially when user accounts need to be added, modified, and removed on a regular basis. As the number of servers increases, the task of administering them increases proportionally. To ease the administrative load, Windows NT Advanced Server implements centralized administration through the establishment of domains. A domain is a group of servers and workstations, typically comprising the computer resources of a small company, or perhaps of a single distinct department or division within a large corporation, such as sales or finance. You can organize your network into one or several domains, depending on the internal structure of your company and the needs of its computer users to share resources and data. When you install each Windows NT Advanced Server, you will be asked to specify a domain name. All of the servers that have been assigned the same domain name belong to the same domain. All of the Windows NT Advanced servers in a domain form a single administrative unit, sharing security and user account information. One server, which you designate as the domain controller, maintains a master database of user accounts with associated group memberships and user rights. Any additions, deletions, or alterations that you make to the user accounts and associated rights are replicated automatically to the user account databases on all other Windows NT Advanced servers within the domain. This means that you have to create and manage only one account for each user. It also means that the group memberships and user rights assigned to the user will be the same on all servers within the domain. When a user logs on, she can specify the name of the domain where her user account resides. Since the account information has been replicated to all Windows NT Advanced servers within that domain, any one of those servers can validate the logon request. The user can then connect to shared resources on any server within that domain. Please note that although user accounts with associated group memberships and user rights are replicated to all Windows NT Advanced servers within the domain, resource access permissions are not replicated. LAN manager servers can also be assigned as members of the domain, and as such, they too will receive updates of the domain user accounts database. However, the server assigned as the domain controller must be a Windows NT Advanced server. Larger organizations may require multiple domains, one for each separate administrative unit. If you create more than one domain, you can establish inter-domain trust relationships between the domains. A trust relationship is a link between domains which makes it possible for users who are logged on in one domain, the trusted domain, to access data and resources in the other domain, the trusting domain. Trust relationships are one-way. To have two domains trust each other, you simply establish a pair of one-way trust relationships between them. When a trust relationship exists between two domains, such as between the sales and finance domains, a network user logged on in the finance domain can access servers in the sales domain even though the user's account does not exist in the sales domain's user account database. The trust relationship enables pass-through authentication, which works as follows. When a user logged on in the finance domain attempts to connect to a shared resource on a server in the sales domain, the server in the sales domain communicates with the Windows NT Advanced server in the finance domain to verify the user's account name and password. If the account name and password are found to be correct, verification is returned to the trusting server in sales, and the user is granted access. Thus, a single network logon enables the user to access his own workstation, all servers within the user's logon domain, and all servers in any trusting domains. To summarize, domains allow easy central administration of a selected set of users, workstations, and servers. Each domain can be administered by a separate authority. Trust relationships enable a user to access servers in other domains without having to add the user to the other domain's respective user account databases. In addition to pass-through authentication, trust relationships provide other important benefits. When a trust relationship has been established, a server's resource access permissions and user rights can be assigned to selected users and groups defined in any trusted domains, as well as to those defined in the server's own domain. When defining a user account in a Windows NT domain, you can designate the account as either local or global. A local user account is so named because the user can be assigned resource access permissions and user rights only on servers within the local domain. In contrast, a global user account can be assigned resource access permissions and user rights not only locally on servers in the local domain, but also globally on all servers in any trusting domains. By default, all domain user accounts are global. Local accounts are typically used when you need to allow domain server access from selected users in untrusted domains. However, you do not want these user accounts to be available for permission and rights assignment on servers in trusting domains. Much like user accounts, groups can be designated as either local or global. Local groups can be assigned resource permissions and user rights only on servers within the local domain, whereas global groups can be assigned permissions and rights not only on servers within the local domain, but also on all servers in any of the trusting domains. To make administration even easier, global groups can be assigned as members of local groups. Then, when resource permissions or user rights are assigned to the local group, these permissions and rights will automatically apply to all local domain users, local domain global groups, trusted domain users, and trusted domain global groups that are designated as members of the local group. To review the concept and usage of trust relationships, let's walk through a typical scenario where a user will access resources on a server located outside of the user's local domain. Joe, a payroll clerk whose account is established in the finance domain, requests connection to the sales history files resource located on the sales info server in the sales domain. Sales info determines that the connection request came from a workstation in the finance domain. Since the sales domain trusts the finance domain, Sales info communicates with the Windows NT Advanced server in the finance domain to request verification of Joe's account name and password. The account name and password are found to be correct. Verification is returned to Sales info, and Joe is granted access. Using a spreadsheet program, Joe then attempts to open one of the sales history files located on Sales Info. Since Joe is a member of the finance domain's global payroll group, which is in turn a member of the sales domain's local liaison group, and since the liaison group has been assigned permission to read from the sales history files, Joe is allowed to open the requested file. We anticipate that companies will take advantage of domains and trust relationships by organizing their network systems according to one or more of the following domain models. This is the single domain model. In this model, no trust relationships are established. Any user who wishes to connect to server resources within this domain must have an account established in the domain's user account database. The single domain model facilitates easy central network administration for companies with few users and shared resources. The number of users that can be efficiently supported in a single domain depends on your domain controller hardware configuration. For example, for best performance when using a 48650 with 32 megabytes of RAM, the number of domain users should be limited to around 10,000. Here we have the master domain model. Network resources are grouped into several logical domains, with one domain designated as the master domain. Accounts for all network users within the organization are established in the master domain's user account database. All other domains trust the master domain. Thus, user accounts can be centrally managed, and global groups need be established only once in the master domain. In this model, all users can log on via their account in the master domain. They can then connect to any server in any domain. Global groups and user accounts established in the master domain are available for resource access permission and user rights assignment on all servers in all domains. The master domain model is a good choice for organizations that want to group network resources into logical domains, yet maintain the ability to centrally manage user accounts and group memberships. However, as previously indicated, there are performance-related limits to the number of user accounts that can be efficiently supported in a single domain. Since the single master domain must contain accounts for all users, this model may not be appropriate for organizations with an extremely large number of network users. This is the multiple master model. As in the previous model, network resources are grouped into several logical domains. However, in this model, there are multiple master domains. All other domains trust one or more of the master domains. This model may be the best choice for organizations that have more users than can be efficiently supported in a single domain, as the large number of user accounts can be distributed across the multiple master domains. Indeed, this model can be scaled to accommodate any number of network users, while facilitating central administration of user accounts and group memberships across the master domains. Administration of the multiple master model can be a little more complex than that of the single master model, since global groups may need to be defined multiple times, once per master domain. This is called the complete trust model. Again, network resources are grouped into several logical domains. Each domain can potentially trust any or all other domains. Each user's account need only be established in the user's primary logon domain. The complete trust model might fit well in organizations that distribute network administration authority, where each department or division assumes full control over its user accounts and network resources. This model, like the previous one, is scalable to accommodate networks with any number of users. A disadvantage of the complete trust model is the large number of trust relationships that may need to be managed. With features such as domains, trust relationships, and global groups, Windows NT Advanced Server provides a rich set of flexible options designed to enable easy administration of systems ranging from small, single-domain LANs to very large multi-domain enterprise networks.
The key to managing large networks with Windows NT Advanced Server is the Single Network Logon, which allows the appropriate users to access data and resources from anywhere in their enterprise-wide network. And using remote access service over phone, X.25, or ISDN lines, administrators can manage remote sites and branch offices, and users, granted the appropriate permissions, can can access data and services on the network from a hotel room or home. Let's turn to our Microsoft Network administrators for their perspective on these features.
One of the things about administration that's exciting as I begin to roll this out and look at our opportunities to administer this worldwide is that you can sit down at a Windows NT workstation and manage all the Windows NT servers in the world. It's pretty incredible when you think about it, that I can sit down and pull up User Manager for a domain, actually, and select any domain that the domain I'm in has a trust relationship with.
Right.
So for example, I'm at my desk and I want to administer the domain in Europe that maintains all the user accounts.
Right.
I can be running a domain version of User Manager on my Windows NT workstation, and you have administrative access to Europe through my account perhaps, and then just log in and I can bring up the user database for Europe and make whatever changes I need right there. And I can actually do that with every single one of them. So even though there's no servers perhaps for the Windows NT Advanced Server domain called Europe, there's no servers locally at my site, so long as I'm on the network or using ISD and RAS, I can connect in from home. Say somebody called me at 2 in the morning and I was the only one available. It was my time on the beeper to be available to support the network. I can have ISD and RAS at my home, go into my office at home, log in, and perhaps solve a problem in Europe and go back to bed.
Windows NT Advanced Server domains can include workstations running Windows 3.1, Windows NT, Windows for Workgroups, MS-DOS, Macintosh, and OS/2 operating systems. This flexibility makes it easier for you to organize computer users and resources into domains that support your company's business structure. But how best to do this? The amount of time it takes to design and implement a Windows NT Advanced Server-based network will vary from company to company in proportion to the size and other characteristics of your network. Let's return to our administrators for some insight into how this process was accomplished across the 150 sites and 30,000 workstations that make up the Microsoft Worldwide Network.
In a enterprise-wide network, such as what we've got here, where we've got literally thousands of workstations, thousands of file servers that are not just here in the Redmond site for Microsoft Corporation, but indeed exist in over 150 sites that scatter the world. And it's a real essential part of our operation. It's an essential operation for providing the information across all of the Microsoft employees everywhere in the world. So we've put a lot of time and money into building this enterprise-wide network that has extensive WAN communications, connecting Redmond to Paris, to London, to all the major cities within the US, as well as really the major cities across the world. Now we have this new thing called Windows NT Advanced Server with its domain structure. How is it that we're going to actually go about applying this domain structure to our business?
The two issues that we had to balance were the WAN structure, line speeds, hub sites, tail circuits, what the physical topology, what the freeway looks like, and how fast it was. And then the business needs of all the individual user communities throughout the entire company. We're talking 16,000 people here, so there was a lot of considerations that we had to take a look at. So my suggestion to anyone thinking about doing this is to look at those two factors equally. And so what we ended up with was a decision that would carry us through the most indefinite period of time that we could think of. So we ended up doing it on geography.
Right.
Because we feel pretty confident that we're not going to be moving sites from city to city. And we feel pretty confident that North America will be North America for a long time. So we hope. So what we did is we broke up the user communities, basically broke up the user accounts based on large geographic areas, and put those in what we call first-tier domains. And then we put all the remote sites, then we put all the remote sites in site domains called Chicago, New York, Paris, London, Singapore, Sydney, all of the remote sites get a city name as their domain. Because we spent a lot of time thinking, what business advantage, what do you win or lose by having just one domain in a city? We decided there really wasn't any trade-off for Microsoft to have just one domain. So we're doing one domain per city. And if you think about it, what'll show up when you go into File Manager and you do a browse is you'll see all the cities, and hopefully you know where the person's data is that you're trying to get to. So that's fine from a business sense, but how did that look to the network? You don't want to stress the network needlessly. It's expensive. So, and we want to keep everything centralized. So what we did is we put all of the Windows NT Advanced servers for each domain in Redmond. And then we put the rest of the servers in that domain, one at each site. So for example, North America is the easiest to talk about. The Windows NT Advanced server, the primary server for North America, resides in Redmond. There's another Windows NT Advanced server for North America, one in Chicago, one in New York, St. Louis, Atlanta, duplicated to provide redundancy, if you will. The protocols allow for the users to be able to sit down at a computer in Atlanta, for example, and be able to access the server here to get authenticated, but it'd be a little bit slow. You have to use the network. It's a waste of resources. And we decided that what we would do is put another server in Atlanta or in these sites so that when the user sits down, they can go to that server. It's locally contained packets and all of that.
But I think one of the important things to remember here is that all Windows NT Advanced servers are in fact domain controllers in the fact that they can validate a login. So this in our particular case, a lot of these servers that you're talking about really aren't new servers. They are servers that were there that we've updated to Windows NT Advanced Server and have given this additional task to.
So we've talked a lot about the remote stuff, but what about locally? And this is the biggest site. Redmond is the biggest site. We have about 8,000 users. It's a huge domain. Well, it's all in one domain called Redmond. And our account database for the Windows NT Advanced server on that domain is about 8,000 or 9,000 user accounts. What's 8 or 9 meg for that database? And it works for us great. We get good performance and
really shows off the scalability aspects of Windows NT, that you can actually have a domain that isn't just a few hundred, but actually a number of thousands.
It's, Alan, I think it's about 8,000 or 9,000.
I think it is. It's about 9,000.
And it's growing. I mean, we're just beginning, and we'll have more groups, and each group is an account, and on and on. But that's just the big Redmond domain. What about all the little business units that are here that we can't have a site domain called Redmond? It would just be a little bit much. So what we did is we took into consideration the business units. And the easiest thing to do from balancing the business needs of the work groups and the business needs of Alan's team, which is to administer all this, was to take large business units that we felt pretty sure weren't going to change, like Word. It's one great big domain. And Excel, one great big domain. Finance maybe would be 2 domains broken up into a couple of secure pieces. And then what we want to do is we want to offload some of the stress from Alan's administrative staff, want to offload that back into the Word domain. So we're actually going to give the people in the Word domain access to administering their own private domain. Because in our case, they're only going to have to administer groups, local groups, and machine accounts. And there'll be no user accounts. So we feel pretty safe letting Word decide how they want to maintain the security of all their systems.
The Windows NT Advanced Server graphical user interface makes the task of managing your network easier and quicker. Alan Jurgen will demonstrate how to set up a user account, create a global group, and grant permissions on files to that group.
What I'd like to talk about today is how we go about setting up user accounts and global groups under Windows NT Advanced Server. Now here at Microsoft, we would get a piece of email from the manager of the new employee with the full name, the location, and the job title. We would use this information to set up the user account. Now I'll double click on Administrative Tools, double-click on User Manager for Domains, and simply select New User. Now our user happens to be Sarah Levant, and for a username, I'll use her first name and the first letter of her last name. So she's set up as Sarah L., full name, Sarah Levant, and under description, I'll put her job title. She happens to be a network engineer. I'll put in the password and confirm that password. Now at this point, I've entered the required information to set up the account. We have many other things to choose from. I could select groups, add her to a group, which I'll talk about a little more later. And profile, we have the user environment profile, which I can basically tailor the environment for the user. Under the user profile, I can do things such as personal program groups and program items. Under the logon scripts, I can select certain network connections that will be established every time this person logs on. And we have a home directory to which I could set so they could have a personal workspace out on the network somewhere. I could click on hours, and I could restrict this person from logging on to certain hours. But for right now, all I need to do is click on Add, and we've set up the account. Now at this time, Sarah has an account to which she could get authenticated from her workstation, but she really has no permissions to do anything. And to give her permissions, I'm going to create what's called a global group. I'll select User, click on New Global Group, and set up a global group called Engineers. I'll put in a description of network engineers, and I'll select the users that I want to be members of this group. Now I could click on the Add button or drag them over. Now, when I click on OK, there's a global group created called Engineers, and it has those two people in it. Now with that global group, I can use that to put down permissions on files. I'll connect up to a server. And there happens to be a share here called drivers. I'll click on that. Okay, now I'm connected to this server and to the driver share. What I'm going to do is click on Security and Permissions, click on Add, and there is the global group Engineers. I'll highlight it, click on Add, and click OK. Now, that global group Engineers has permission to access that data.
Security exists throughout Windows NT Advanced Server. User accounts, groups, and domains all utilize security features meant to ensure that only the appropriate people have access to data. The user first encounters Windows NT security when she logs on. Network engineer Debbie Alsop.
One of the really great things about Windows NT is that with a single network logon, I can access resources anywhere in the network where I've been given permission. To log on, I hit Control-Alt-Delete. Control-Alt-Delete captures the attention of the system in such a way that if anyone's written a program that mimics Windows NT, it can't capture my password. In the Welcome dialog box, I'd enter my username. Then I need to choose the domain where my username is kept. In this case, my username is maintained in the Redmond domain. Enter my password. I'm now logged in, can access resources anywhere in the network where I have permission.
After you've organized the structure of Windows NT Advanced Server domains, the next consideration is the physical location of the Windows NT Advanced servers. The location of the primary domain controller is particularly important because it contains the master copy of the user account database. Changes to that database, and only the changes, are replicated to the backup domain controllers every 5 minutes. Let's hear how our administrators decided to place their Windows NT Advanced servers to best take advantage of the Microsoft Wide Area Network.
One of the things that we struggled with in just trying to decide how to set up our master user domains, the first tier domains that have all the accounts, was where to put the primary domain controller for Europe or for some of these remote sites. And I remember a lot of our discussion is like, if we put it in Europe and it replicates every 5 minutes, are we going to want it to go across the link between here and Europe 18 or 20 times or 30 times, however many sites and DCs we have over there? Are we going to risk putting it over there and not having it, you know, in our secure environment here? And so the decision was made to put it there, and it seems to be proving out that this way there's one replication that comes back, or two maybe replications that come back to Redmond.
It just replicates the changes, so that's going to keep that very small. Even if it does stack up, if your links go down, it's never going to get that large to where you can't replicate it.
Right.
So as important as primary domain controllers are, they still don't have to reside physically with the group that is ultimately responsible for them.
No, but by having the backup domain controller here, if something did happen in Reading, where the primary is, and the hot standby that's right there also failed for some reason, we can easily promote one here in Redmond, and we're covered. So you always have that option of, so long as you have enough domain controllers and you think about that logically about where you want them, you can always promote any one of those domain controllers in that domain to the primary, the one that does the initial administration.
The flexibility and scalability of Windows NT Advanced Server domains allow organizations to tailor their networks so that the various kinds of information are available to people with varying responsibilities, wherever those people are physically located. Debbie Alsop will demonstrate the single network logon by setting up a trust relationship. She will also demonstrate the procedure for promoting a Windows NT Advanced Server to domain controller.
We're going to establish a trust relationship between the second tier domain where my workstation is and the first tier domain where my user account is. Now I can do this from this workstation because I have administrative privileges in both domains. A trust relationship has two sides. The first side that needs to be set up is the side that's permitted to trust this domain, which in this case is Redmond. So I want to go into the user manager for Redmond, go to Policies, and select Trust Relationships. And I'm going to add my second tier domain to the permitted to trust this domain. Type in Bill O, which is the name of my second tier domain. Type in a password, which I'll use to set up both sides of the trust. I'm going to close that connection, go to my second tier domain, Bill O, and do the same basic steps, go into Policies, Trust Relationships. Only this time I'm setting up the opposite side in the trusted domains, and I'm going to add Redmond as a trusted domain. I'm going to type in the same password that I set up on the other side. When the two domains have completed setting up the trust relationship, you'll get a dialog box that will tell you that it's done. In this case, the dialog box says Trust Relationship with Redmond successfully established. Now we have a trust relationship between the second tier domain where my workstation is and the first tier domain where my user account is. Now whenever I need to log into this system, I can log in using my Redmond account and be validated into the network. Sometimes hardware fails, and when that hardware is an integral part of the Windows NT Advanced Server domain and the systems are all counting on the hardware to be up, you need a fast recovery method. The Windows NT Advanced Server folks have designed in a method of recovering very quickly. When Server Manager comes up, you have several options. I want to view all the devices that are in the Redmond domain. And since Redmond is just a domain that contains user accounts and doesn't contain workstations, there aren't very many devices in this domain. But let me change to a domain that does have a lot of systems. This domain has literally hundreds of systems. It's a very large Windows NT domain. We have different ways of being able to view this. Currently, we're seeing all systems in the domain, but in my case, I just want to look for the Windows NT Advanced servers in this domain. And there's quite a few. Now, you'll notice there's a little icon associated with the computer name. If you go down this list of icons, you'll notice one that's unique. And it also has a type description as controller. This is the primary domain controller in the Windows NT Advanced Server domain. I want to take and promote a different computer to being a primary domain controller at this point, because I need to take the current domain controller down and rebuild it. Hypothetically, this is something that you might want to do if you wanted to add more memory or add more hard disk or just do regular maintenance. So in this case, I'm going to go to another server, and I'm going to go into the computer option and choose Promote to Domain Controller. And I'm going to promote the spork to primary, and it may take a few minutes, but this is all that's required, is to say yes at this point. And then the servers will take care of all the business necessary, and a few minutes the icons will change and you'll notice that the other one's been promoted, at which time then you could take the original primary domain controller off the network.
Under Windows NT Advanced Server, setting up a network printer and printing to it are easier than ever. Let's go to one of Microsoft's centralized computer rooms where Alan Jurgen will demonstrate how to do this.
What I'd like to do is walk you through setting up a print server under Windows NT Advanced Server. Let me explain the environment here a little bit. We've got some PC servers set up in a rack with a concentrator that will allow me to switch from Windows NT Advanced Server to my Windows for Workgroups. Now, in setting up this printer, I'm logged in as the administrator on this server, and I'm going to double click on the Print Manager. I'll go over here under Printer and click on Create Printer. We'll put in a printer name. In this case, it will be a printer for this building, Building 11. You've got to then select the driver, to which there are hundreds of drivers to choose from, for the appropriate printer. In this case, we'll go with an HP LaserJet series, HP LaserJet 3 SI. A description of the printer. And we will click on sharing this printer on the network. It automatically puts in the share name, which will be MS11, and we can put in a location here, which is a very nice feature. We can put in the location of the printer. In this case, a room in this building. Click on OK, and the printer's set up. Now the printer is set up, it's ready to use, and it's also shared out. I can switch over to my Windows for Workgroups, select the Print Manager, look under Printer, and connect to a network printer. I can view all the printers, existing printers, and the new one we've set up. Double click on it, and I'm ready to print.
Administrators require easy access to system information to help troubleshoot and identify potential bottlenecks. The Event Viewer enables administrators to view system, application, and security events within Windows NT Advanced Server.
But it's not just having that information, it's also how you present that information
It's
and
very
how
easy
you
to use.
manipulate
The
it.
Event Viewer is a very It's a very easy to use application. You can view the events, you can set it up in certain ways that you can view based on priorities. The system events, security, which, as Debbie said, the unsuccessful, successful logins, printing, as much detail as you want to get, and the application events, which would be from, say, an email or a database application or something storing in there. And then you can, view the ones that are important to you and pertain to your server, your domain.
During the course of this video, you've become familiar with many of the concepts and features you will apply to the design, implementation, and management of Windows NT Advanced Server in your network. You may still have questions about this system. Here are some of the more commonly asked questions we've received from our customers.
I'm about to install Windows NT, but first I need to know what the difference is between a workgroup and a domain.
A Windows NT-based workgroup is simply a grouping of computers running Windows NT without a Windows NT Advanced Server. Each workstation running Windows NT is responsible for maintaining its own user account database. A domain is a group of Windows NT Advanced Servers and client workstations that share a common user account database.
I'm curious about user profiles and the user profile editor. Exactly what are user profiles and how would I be able to use them in my work?
A user profile is the most flexible method administrators have of managing user environments on a Windows NT workstation. A profile provides a snapshot of a specific user's desktop environment, including program manager groups and program items, network and printer connections, and other characteristics. There are two kinds of user profiles, personal and mandatory. The personal profile can be changed by the user, whereas the mandatory cannot be changed by the user.
Sounds like user profiles could be very useful. I have noticed, though, in the new user dialog box, this profile button that brings up the user environment variable dialog box. In that, I noticed logon scripts and home directories. Exactly what is a logon script? How would I use that? And what's the home directory? How would that be useful to me?
A logon script is a file that runs automatically when a user logs on at a workstation. There are a few reasons why you may want to use logon scripts. You may want to manage only part of the user's environment, such as network connections, or you may already have LAN Manager 2.0 or higher and want to continue to use logon scripts you have created. Home directories can benefit both users and administrators. A home directory is a personal data storage space for an individual user. For workstations with low disk storage space, an administrator may want to assign each user a home directory on a server. In addition, administrators can consolidate storage space and centrally manage file security.
I've just started User Manager for Domains, and I noticed that it has something called a guest account, but it's grayed out. What do I use a guest account for?
By default, every Windows NT Advanced Server domain and every Windows NT workstation initially has a guest account defined, but for security reasons, it resides in a disabled state until an administrator activates it. There are two kinds of guest logons, local guest logons and network guest logons. With a local guest logon, the user can work on the local computer, subject to the rights and permissions the administrator has granted the guest account. A computer may allow a network guest logon for users not contained in its user account database. The guest user then has all rights, permissions, and group memberships on the computer that are granted to the guest account.
I've opened the Policies menu under User Manager for Domains because I want to set up trust relationships between domains. But a question just occurred to me. Under Windows NT Advanced Server, if the finance domain trusts the sales domain, does the sales domain automatically trust the finance domain?
No. As an added security precaution, trust relationships are designed to be one-way and must be set up individually. For two domains to trust each other, a pair of one-way trust relationships must be established.
I want to use one of my LANman 2.1 servers with my Windows NT Advanced Server domain. Before I set it up, I need to know what level of functionality I can expect.
A LAN Manager 2.0 or higher server can keep a copy of the domain's user account database and perform all of its usual functions. However, it can only operate as a backup domain controller and cannot validate logon requests for Windows NT machines.
We have a number of Macintosh computers on our network. Can we include them in a Windows NT Advanced Server domain?
Yes. Windows NT Advanced Server integrates all the tools you will need to include Macintosh users as members of those domains. Because there is no difference between administering Macintosh users and PC users in Windows NT Advanced Server domains, you will not have to learn additional procedures. You also will not need to add software to the Macintosh desktop to connect to a Windows NT Advanced Server.
I understand that Windows NT Advanced Server includes TCP/IP. Why did Microsoft include it? And in what situations can we use it?
Windows NT Advanced Server includes several network protocols, including NetBEUI, IPX, and TCP/IP. However, TCP/IP is Microsoft's strategic protocol for wide area networking. It can serve as the only protocol connecting PC desktops and Windows NT Advanced Servers. TCP/IP also provides a reliable foundation for Unix connectivity applications such as FTP and Telnet. Windows NT includes many common utilities that have been designed to access and transfer data in mixed environments. And the inclusion of the Windows Sockets interface offers a compatibility with many foreign host connectivity products and is ideal for developing client-server applications. We hope this introduction to concepts and planning information has answered some of your questions about how to implement Windows NT Advanced Server. At Microsoft, we believe in information at your fingertips. Windows NT Advanced Server represents our proud commitment to achieving that goal.